Well, good morning. This is Thursday, the 2nd, I believe it is, of November 2017. It's 11 o'clock in the morning. Should be linear algebra class. Right now, I'm the only one in the room. Hopefully, the students will be coming in soon, but I'm going to get started because we can't really afford not to cover as much material as possible. We're in Chapter 3, Determinants, at Section 3.3, Properties of Determinants, and top of page 122, Determinants and the Inverse of a Matrix. Now, it just dawned on me, I guess I returned your first test to you. Okay, I was a little worried there that I hadn't returned your first test, but I think I have, okay? And I believe you still have the second test out. I believe you do. And we're almost at the point of being ready for the third test. So please try to get that second test in as soon as you can. Now, here's the deal on the top of page 122. Trying to think if there's any other announcements I need to make. I think my office hours are back about normal, though I've said this several days, but I believe it's true now. My Tuesday, Thursday office hours are technically 1:15 to 3:15, though I can adjust that because my lunch hour is 12:15 to 1:15, but I can meet with you at 12:15 if that's more convenient, and then I'll have my lunch hour a little bit later. So I can work around that. And then Tuesday and Thursdays, that's that. Friday, by the way, is 7:45 to 11:45, unless there's meetings called, which I don't know of any right now. And then Mondays and Wednesdays is 3:15 to 5:15. And I don't think those are going to change too much for a while anyway. So it'll be rare and random when they do. Okay. Notice here, we get at the top of page 122, it says, it can be difficult to tell simply by inspection whether or not a matrix, especially if it's 3 by 3 or greater. Now, if there's a 2 by 2 matrix, those are pretty easy to tell if it has an inverse, okay? But 3 by 3s, just glancing at them, not going to make it. Here's the example they give. Let me get my pen activated, if it'll activate here. Okay. Here's matrix A, a 3 by 3 matrix, 0, 2, negative 1. 3, negative 2, 1, and 3, 2, negative 1. Okay, here's matrix B. And if you think they look pretty similar, you're absolutely right. 0, 2, negative 1, 3, negative 2, 1, and 3, 2, 1. Almost identical matrices. That last entry in B is plus, whereas the last entry in A is negative. Now, can you tell, just by looking at those, which of these two is invertible and which is not? Okay? Just by glancing, actually, yeah, you can. Okay. If you remember that the last theorem we had, I don't know if it's the last one, a previous theorem, yeah. If a square matrix of order n, I'll have to scoot back a little bit further. Didn't remember it being this far. Okay. Conditions that yield a zero determinant. This is theorem 3.4 back on page 115. If A is a square matrix and any one of the following conditions is true, then the determinant of A is 0. If an entire row or column consists of zeros, certainly the determinant is 0. If two rows or columns are equal, then the determinant is 0. Or if one row or column is a multiple of another row or column, then the determinant is 0, because you can row reduce it away. Well, the theorem we're going to hit next is a square matrix is invertible, meaning non-singular, if and only if its determinant is not equal to 0. Now, we already hit that back with 2 by 2s, remember, even before we started talking about determinants in this chapter when we were doing it before. If the determinant of a 2 by 2 matrix is 0, it didn't have an inverse. If it did, it did have it. If it was other than 0, it did have an inverse. Well, the same thing holds here, but from that theorem I talked about earlier, if 2 rows or columns are multiples of each other, then the determinant is 0. And if you look at A and look at column 2 and column 3, negative 2 times column 3 is going to be exactly what column 2 is. So this one, the determinant would be 0. So therefore, non-invertible, otherwise singular. Okay? Whereas B, though you can't say for certain, but none of those rows or columns are multiples of each other, and that still doesn't guarantee the determinant's not 0, but at least it has a chance of not being 0. Okay? There is a little discovery over on the left column, and sometimes I think these are worthwhile and sometimes not. But now I've done this one in the past, I think this might be a decent one. So let's do this discovery. Here's another matrix A. Again, a 3 by 3. 6, 4, 1, 0, 2, 3, and 1, 1, 2. Okay? Matrix A. Says use a software program or graphing utility to find the inverse of A. Oh, boo hiss. Okay? I don't have either one of those readily available. Okay? So we're just going to have to find the inverse. Okay? So what I'm going to do is write the augment this matrix with the identity matrix. Okay? It's 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? Now, we need to row reduce this big matrix. First thing I'm going to do is exchange those 2 rows. So that becomes 1, 1, 2, 0, 0, 1, 0, 2, 3 stays the same, 0, 1, 0, and 6, 4, 1, 1, 0, 0. Okay? Sorry. Man, back, my neck, everything is just all tense. I think it's because it's cold in here and I'm holding my muscles tense, and it's really beginning to give me a pain in the neck, literally. All right, next we're going to do -6, row 1, plus row 3. Okay, we're going to make the 6 a 0. You got a 1 where you need a 1, the 0 beneath it, you need that to be a 0. So that's going to lead to, we're going to leave the first row alone, 1, 1, 2, 0, 0, 1, and leave the second row alone, 0, 2, 3, 0, 1, 0, and the new third row is going to be -6 times 1 is -6 plus 6 is 0. -6 times 1 is -6 plus 4 is -2. Minus 6 times 2 is negative 12. Plus 1 is negative 11. Minus 6 times 0 is 0, plus 1 is 1. Minus 6 times 0 is 0, plus 0 is 0. And minus 6 times 1 is minus 6, plus 0 is minus 6. All right. Now this is a really big boo hiss, okay? Because nothing's going to be real simple on the next one. So before I change the two in the second row to a 1, I'm just going to add those rows 2 and 3 together. Okay? So this will produce 1, 1, 2, 0, 0, 1. And adding the two of those together will be a 0, 0, negative 8, 1, 1, negative 6. Okay? Now I'm going to divide the second row by 2. Okay, that'll be a 0, 1, 3 halves, 0, 1 half, 0. Okay? Got those fractions in there. Now what we need to do is get a 1 above this leading 1 in the second row. So we're going to do minus row 2 plus row 1. Okay? I think I'll have to come down here to do it. That's going to be the new row 1. So it'll be a 1, a 0, sorry about that. Should write it down. Yeah, there it is. I have written it down. Okay. Minus row 2 plus row 1. That'd be a minus 3 halves plus 2, which is 4 halves. So that'd be a 1 half. That'll be a 0. That'll be a minus 1 half. And this will be a 1. Okay? Other two rows stay the same. 0, 1, 3 halves, 0, 1 half, 0, and 0, 0, minus 8, 1, 1, 6, or minus 6. Hope I got it right. Okay. Now this is really getting messy because that bottom row I'm going to have to divide by negative 8, and that gives you a 0, 0, 1, negative 1 8, negative 1 8, positive 3/4. All right. So this will become, don't keep the top root 2 rows the same, 1, 0, 1 half, 0, negative 1 half, 0, it doesn't look like it. For some reason, the pen is very, very slow this morning. This is 0, a negative 1 half, and 1, a 0, 1, 3 halves, 0, 1 half, 0. Okay, and a 0, 0, minus 8, going to divide. I'm sorry, my throat is on the way out, it sounds like. And I don't know why. It's just been a long, tedious week. So we're dividing, I'll probably do row 3 divided by negative 8. Okay. 0, 0, 1, negative 1, 8, negative 1, 8, and positive 3 fourths. Okay. This is, now I'm beginning to regret I did this discovery because it said use the software or thing, and I didn't have those. Okay, so what we've got to do now is get zeros above that. All right. Now I'm going to save my first matrix A, but I don't think I need to save anything else. Okay? So let me erase. Okay. Boy. My head is just aching like crazy. I don't usually have headaches. This thing is erasing so slowly. So incredibly slowly. Well, it just won't erase. There we go. Okay. Oh, man. This is so incredibly slow. I can't believe it. All right. One of these days it'll finish, but man, it's taking its sweet time. Okay. Whew. That was forever. All right, there was our original matrix. This is how far we've gotten so far. Now, on this one, what I want is zeros above that third leading one. So the first one is going to be negative 1/2 row 3 plus row 1. The next one's going to be negative 3/2 row 3 plus row 1. Okay? No, row 2. All right. So let's go up here and do that. Actually, I'll go do it down here. Trying to conserve some space here. Okay, your third row we're going to leave alone. 0, 0, 1. Now, I can't read my writing, and I've erased the others. Is that a 1/8 or a negative 1/8? I think it's just a 1/8. So it seems like they had the same sign. Yuck, I'm hating this. I've already erased the other. I can't tell. But we're within just a few steps of finishing. In fact, 2 steps that we would have it finished. The next thing it asks us to do is take and I'm sorry I erased my previous line and I can't tell. I think that is a minus 1/8. I'm going to write it as if it is. Okay? I hope I got it right. And negative 1/8 and a 3/4. Because it seems like those two signs are the same. All right. Doing the top one, that's going to be a 1, 0, and negative 1/2 times 1 is negative 1/2 plus 1/2 is 0. And negative 1/2 times a negative 1/8 is positive 1/16 plus 0 is positive 1/16. And negative 1/2 times negative 1/8 is positive 1/16 minus 4/16. I hope that's a minus there. So positive, yeah, positive 1/16 minus, and I said 4, is 8/16. That would be minus 7/16. And minus 1/2 times 3/4 is minus 3/8 plus 1/8 would be 5/8. Okay. Minus 3/2 row 2, row 3 plus row 2 is going to be a 0, and this will be a 0. And minus, goodness, I'm cold. Minus 3/2 times minus 1/8 is positive 3/16. So that's a 3/16. I hope. And this one will be minus 3/2 times minus 1/8 is minus 3/16 plus 8/16 will be 5/16, I hope, and minus 9/8. Okay, I hope I've got them right. Okay, so we are hoping this is A inverse. I'm going to pull out a 16. 1/16. That's going to make this 1 minus 7, 10, 3, 5, negative 18, okay, minus 2, I hope it is, minus 2, all right, I think that's a 12. All right. There's no guarantee this is going to work, but let's give it a shot now. What it says to do here is find the determinant of each of those. Well, the determinant of this one, I think I'll go with the second row here. Okay, the first entry is going to give you a 0. The determinant of A is going to be 0. This is a positive position here, so it's a 2 times the determinant of what's left over. 12 minus 1 would be 11. Okay. All right. And that's going to be a minus 3 because its position is a negative position. And it'll be 6 minus 4 is 2. All right. The determinant of this is 22 minus 6 would be 16. I hope. Okay. Now this determinant is going to be a real pain in the neck. All right. And I think to do this one, I'm going to do the expansion. Okay. Oops. This may be worth it just doing it. For this reason, just to remind you how to do the expansion. You copy the first 2 rows over, first 2 columns over. 1, 3, negative 2, and negative 7, 5, negative 2. Okay. Now, it's not really a matrix anymore. We're doing a determinant, and what we do is do the positives down here. 5 times 12 is 60. This would be a minus 126. No. Wait. I was doing a partial. For some reason, goodness, that's slow. I thought it wasn't even active. Okay. That's your 126 times 2 is 252. Okay? And then this is going to be another negative, minus 60. Really? Nice. So those 2 go off. That's okay. Now we do our negatives going upwards, so I think I'm going to erase these construction lines I did. Easier said than done. Alright, the first one's going to be a plus 100, because it's minus going upward, and that's a minus sign. And this will be a minus. 2 times 18 is 36. And the last one here is a plus 84 times 3 is 252, I think. It's going to be plus 252. All right. See, oh, that's nice. These 2 go out. So that leaves me just simply 64. And (1/16) of 64 is 4, not 16. So I think I made an error on it. Okay. Sorry about wasting that much time. Sorry about that. I erased too soon and couldn't tell my signs. Okay. Let's do example 3. I think these will be much easier. All right. Which of these matrices has an inverse? 0, 2, minus 1. Oh, these are the ones we looked at the top, aren't they? Okay? We know that A, the determinant, is 0. Okay? So that one's completely out. So let's only consider B. And it starts as, and the reason A's determinant is 0 is that the second column is a multiple of the third column. That requires the determinant to be 0. All right? So that's a singular matrix that has no inverse. Okay? So So let's do the second one, 0, 2, negative 1, 3, negative 2, 1, and 3, 2, negative 1. Okay? We're going to do it, whoops, positive 1. Put the wrong one. All right. So what we're going to do is do its inverse. Its determinant. Okay? Now, here, looking at the possibilities here, I either need to do the first row or first column because that's got the only 0 in it. I'm going to opt for the first row, and the determinant of this is going to be a minus 2 because that's in the negative position times the determinant that's left over here, and that's 3 minus 3 is 0. All right, that wasn't hard. And then the minus 1 is in a positive position, so it doesn't change its sign. And let's get these construction lines out of there. And the product here is 6 plus 6 is 12. Minus 1 times 12 is minus 12. So without worrying about what its determinant is, we see that, without what its inverse is, we know it has an inverse because that negative 12 is not 0. All right, now here's the theorem that we would have done on our discovery if I hadn't made an error. And here's this theorem. If A is an n by n, so it's a square matrix, but also it tells us it's an invertible matrix. Okay, that means it does have an inverse. Then, if that's the case, then the determinant of the A inverse is 1 over the determinant of A. Okay, that's what we should have gotten on that next one, on that discovery. Well, I made an error somewhere along the way, and it was a sign error, I think. Well, I don't think it was a sign error. I couldn't read and tell what my signs were, and therefore I assumed it was the other one, and I think I assumed poorly. All right. Now, there is a nice little proof here for this one. If A is an n by n invertible matrix, then we know that A inverse exists. Otherwise it wouldn't. And we know the product of those two would be the identity matrix. Okay? And I think we've already determined from an earlier theorem that the determinant of a product is the product of the determinants. So that tells you that determinant of A times the determinant of A inverse, well, the determinant of the product is equal to this, the product of the determinants, and that's equal to the determinant of I. Determinant of I is that just is 1, okay? So that then tells us that A inverse, determinant of A inverse, is equal to 1 over the determinant of A. Now, the only other thing that you have to throw in here is determinant of A can't be negative because they told you A was invertible. If A is invertible, its determinant can't be negative. So, can't be 0. Didn't mean to say negative 0. The determinant can't be 0 because we just divided by it. But guess what? If A is invertible, its determinant cannot be 0. Okay. So that proof wasn't too bad. Let's look at example 4. Okay. And because sorry, because my throat is getting sort of clogged up, it's really cold in this classroom. Even though I wore heavier clothes today, it's still bugging me. My ears are cold, everything. I'm going to run down to my office for just a moment, so I'm going to put this on pause.